Hello and welcome to today's video. Okay, I wanted to start by really going over last night's homework. Rather than going over a couple questions that people had, I want to show you all the answers so that you can check your work because I'll know all the answers weren't completely on my answer key. So get out your homework from last night. I really want you to see if you made mistakes, where you went wrong. Very few people get all of these right on the first try, especially because missing negatives is easy and drawing them in the wrong quadrant. So let's go through this. Okay, top row should have looked like that. Make sure going left is negative. When I say left and down, this is left, this is down. So that's negative, this is down, so that's negative, and that should be it for the top row. Obviously, if you need to pause the video to check longer, go for it. Here's the middle row. Again, check your negatives. Here's left and down, both negative. Hypotenuse is never negative though. Just down here, left and down. Bottom row, negative because it's down. Left and down is negative, just left. Okay, over on the back. There's the top row, nothing negative in 10. Some people had this side negative, but that's going to the right. This is left. There's the middle row. So like a lot of people are putting this in quadrant 1. It would be in quadrant 1 if it was a positive angle, but remember it goes all the way around clockwise and then some. These looked pretty good. Didn't have any major issues on those. A couple people did ask about coterminal, and there's more answers than just the ones that were on the answer key. I like that some people were putting radians in there, like negative pi over 3. That's an awesome answer. But coterminal just means they land in the same spot. So what I was saying is, okay, start with my negative 60, which is right here. Just keep adding 360. If I go all the way around, I'm going to end in that same spot again. So 300, 660, when I go around more than once, 1020. Anytime I add 360, I'm going to land in another spot that's the same. Just think about it, 360. If this is where I am, add 360 to it, I'm there again. Add 360 to it, I'm there again, etc. You can also subtract 360. That's fine. You could give radian equivalents. That's fine. But coterminal just means it ends in the same spot. So adding or subtracting 360 is the easiest way. Okay, before we get into today's notes, which is on your own paper again, so hope you have some paper to do that, take a minute and see if you can remember the reference formula or reference angle thing we talked about yesterday. So why don't you pause the video and try to tell me the reference angle for each of the following angles. Did you have a chance to try it? Okay, so I was trying to show you yesterday that radians are really easy because a reference angle is a radian. In a radian is always one slice of the pizza. One slice of the pizza would be pi over 4 or pi over 6 or pi over 3. It's whatever number is on the bottom. So anytime you're over 4, you want to think 45 degrees. Anytime you're over 6, that's always 30 degrees. Over 3, 60 degrees. This would be 45 degrees again because it's over 4. And if you need more explanation of that, we'll talk about converting between degrees and radians in a couple days. But think about it as you have, like here's over 4. That first day, I don't really use this that much, but I talked about the 4 pizza slices up top. 1, 2, 3, 4. So if this is pi, which is really like 180, if I divide that up into 4 slices, which I did not do very good in my picture here. Got an extra slice over here. But anyway, if I divide that up into 4 slices, then if I have 180 degrees total divided by 4 slices, each one's 45. So 45, 45, 45, 45. But all you really need to know is over 4 is always 45, over 3 is always 60, over 6 is always 30. Now when you get to these, you kind of have to draw it out. 150 degrees is over here in quadrant 2. That's 150. So the reference angle is this missing piece right here, which would be 30. And how do you get it? 180 minus 150. 330 would be down here. That's 330. Missing piece has to get you to 360, so that's also going to be 30. This time I did 360 minus 330. And I was trying to show you yesterday that you're always going to kind of subtract from or subtract off the line you're attached to. And I'm either going to be attached to 180 over here or 360 over here. Mathy random fact today: a one-day weather forecast requires about 10 billion math calculations. Math is life. Okay, so today is the conclusion of why we did everything yesterday. So this is Unit 13, Day 4. And you can call this Evaluating Trig Functions, Part 2. Okay, so yesterday I just gave you angles. Today, if I tell you to evaluate, you're going to have a trig function with an angle. So now the reason we did yesterday was to set us up for evaluating something like sine of 135. And remember, that's not sin of 135. You sound like a fool if you say that. It's sine. S-I-N-E is how it's spelled. Okay, the other thing that I'm going to need to remind you of is, in addition to what we did yesterday, your two special triangles. So if this is 30 and this is 60, what side's always next to the 30? X radical 3 next to 60 is x, and the hypotenuse is 2. With a 45, 45, 90 triangle, the two legs are both x, and the hypotenuse is x radical 2. Now I showed you yesterday that, oops, sorry, this was 2x, I guess. I showed you yesterday that the x's don't really matter, because when I do these SOHCAHTOA, which is the part I'm going to add today, the only thing we didn't do yesterday. When I do SOHCAHTOA, when I take one of these sides and put them over the other, the x's, no matter what sides I pick, are always going to cancel out. So since we're going to cancel the x's and reduce them anyways, we might as well just say x is 1. So this is going to be 1, 2, radical 3. And this is going to be 1, 1, radical 2. Okay, so let's get back to the example. Sine of 135. You're going to start exactly like we did yesterday. And you're going to draw that picture. So we're going to do 0, 90, 180, 270, and 360. I still want you to be writing those quadrants out. 135 would be in which quadrant? Quadrant 2. That's 135. We draw our triangle straight down to the x-axis. Excuse me. Got to figure out our reference angle. So if this is 135, what's this piece going to be? It's 45. And where'd that come from? From doing 180, which was all the way to the straight line, minus off the 135. Okay, so it's a 45 triangle, which means this is 1, and this is radical 2. Should any of those be negative? Left. So that's a negative over there. And that's what you did yesterday. The only thing we're adding today is, if I want to find the sine of 135, using SOHCAHTOA, sine is opposite over hypotenuse. And we're always doing it based off of the reference angle. So it's in reference to that angle right there. So what's the opposite side here? Across from 45 is 1. Hypotenuse is obviously radical 2. And we want simplest radical form, so multiply top and bottom by radical 2. You have radical 2 over 2. So really, that last step is the only new piece. I shouldn't say the only new piece, because the other thing I want you to be able to do is to check your work. And the way you're going to check it is with your graphing calculator. Now, the one thing you got to watch out for is the mode. Okay, so if you look at your calculator real quick, whether you have a new calculator or an old calculator, this is pretty much the same. Whenever you touch a trig button, sine, cosine, or tangent, which are right in the middle here, you have to check the mode first and get in the habit of doing that. So hit mode. And probably the second or third or fourth one down says radian or degree. I'm doing sine of 135. Do you think I want to be in radian or degree mode? Obviously degree, because 135 is degrees. So you got to go down here, switch over to degree. Then you can quit out of that. We want to find sine of 135. Sine 135. And it gives me a crazy big long decimal. Math for x not going to do anything because it's an irrational number. So I want you to write out sine of 135 equals that decimal, 0.7071, blah, blah, blah. How do I know that's the same? Well, I know that sine of 135, now type in your answer for radical 2, or of radical 2 over 2. Radical 2, get outside of the radical, over 2, same big long decimal. So that's how you're going to check. If you get the same big long decimals out, you know you got it right. So you can't do this whole process just on your calculator because that's never going to give you this number. But you can at least use your calculator to make sure you got the right number, especially whether it's positive or negative. If you forget negatives, the calculator will tell you if it should be negative. So on the homework tonight, and I'll give you an example when we get started, I want to see, this would be one question. I want to see the picture. I want to see that work to get your answer. And I want to see a check that looks like this where you compare two decimals. Okay, let's do another example. Example 2. We're going to do tangent of 11 pi over 6. Draw it out. So 0, pi over 2, pi, 3 pi over 2, and 2 pi, because we're in radians this time. So if I'm over 11 pi over 6, what quadrant is that going to be in? I'm over 6, so this is 6 pi over 6. This would be 12 pi over 6. I know some of you like the pizza slice idea, so 6 slices on top, 6 more on the bottom to get to 12, but I got to stop at 11. So 11 is just 1 before 12. That's your angle. Draw your triangle. What's your reference angle? It's over 6, so 30. 180 divided by 6 slices would be 30 each. What side's always next to 30? The 3's hang out together, so that's radical 3. This would be 2. This would be 1. What's negative? The 1, because that's going down. Okay, so then tangent of 11 pi over 6. SOHCAHTOA, tangent's opposite over adjacent. And again, we're talking about from the reference angle. So what's opposite 30? Negative 1. What's adjacent to 30? Not the hypotenuse, so radical 3. And multiply top and bottom by radical 3 to get it in simplest radical form. So negative radical 3 over 3 is what we end up with. Okay, so when we check, what mode should I be in this time? 11 pi over 6 is a radian, so I got to change to radian mode. So the first thing you're going to do on your calculator is you're going to type mode. You're going to go down to radian instead of degree. Then you're going to try tangent of 11 pi over 6, which gets you negative 0.577. So on your homework, you'll show me tangent 11 pi over 6 equals negative 0.577. Then you're going to type in negative radical 3 over 3 and see if that's the same. So negative radical 3 divided by 3. Same big long decimal. Shows you it's negative, so we got that right too. You know you got it right. Okay, I'm going to flip my page. Hopefully you're getting the hang of it. Hopefully you see why it's pretty much like yesterday. Next up, we're going to do cosine of negative 120. So our first step is to draw it out. It's a negative angle this time, so go clockwise. 0, negative 90, negative 180, negative 270, and negative 360. So remember, we just go clockwise around. So starting from here, I go this way around. That's my negative 120. Draw your triangle. What would your reference angle be? I'm attached to 180, and I've got 120. So the missing piece would be 60. 180 minus 120. What side's next to 60? 1. Hypotenuse of this is 2. Radical 3 is over here, because that'd be next to the 30, which is up here. Anything negative? The left is, and the down is. Okay, so if I want to evaluate cosine of negative 120, we're going to do adjacent over hypotenuse from SOHCAHTOA. It's adjacent to your reference angle. Negative 1. What's the hypotenuse? Crossing the right angle is 2. So negative 1/2. Check. What mode? It's negative 120 degrees. So hit the mode button, go back to degrees. Mode degree. Then type in cosine of negative 120. Negative 0.5. This one's easy to check because you obviously know if cosine of negative 120 is negative 0.5, your answer of negative 1/2, you know that's also negative 0.5. Don't even have to type anything in. Check. Okay, number 4. Let's do tangent of pi over 3. This would be a good one to try on your own. So if you want to pause the video and see if you can get this one, be my guest. If you're ready to see it, here we go. 0, pi over 2, pi, 3 pi over 2, 2 pi. What quadrant's pi over 3 in? It's just 1 pi over 3. This would be 3 pi over 3 if I was over here. So 1 pi over 3 is closer to 0. Or of your 3 pizza slices, it's just your first one. That's your angle. Draw your triangle in. What's your reference angle? You're over 3, so that's always 60. So next to 60 is 1. Hypotenuse is 2. This side's radical 3. Anything negative? Nope, because we're all in the first quadrant, right and up. So tangent is always what side over what side? It's opposite over adjacent. So the opposite side, opposite of your reference angle, is radical 3. Adjacent to it, next to the 60, is 1. Radical 3 over 1 is just radical 3. For your check, what mode are we in? Back to radians, because pi over 3 is a radian. So in your calculator, you're going to type mode. We're going to go to radian. Then we're going to type tangent of pi over 3, giving me 1.732. To check if your answer is right, you're going to type in radical 3, which is the answer that you got. 1.732. Now, obviously, if you get a different long decimal, it means something you did was wrong. So go back and check your triangle again, check your negatives, check your reference angle maybe. But that'll at least tell you if you're right or not. Okay, 2 more and I'm done. Quick notes day today. Example 5. Sine of 585 degrees. What quadrant's that going to be in? Let me set it up. 0, 90, 180, 270, 360. 585 is obviously more than 180 or more than 360. So we got to take 585, subtract off 360 to see where we land. That's a 5, that's a 2, 225 degrees. So if it was 225, where would it be? Quadrant 3. We went all the way around, plus a little more. Reference angle. We got to do it based off of 225. And I'm attached to 180. So 225 minus 180 is 45. So this is a 1, 1, radical 2 triangle. Anything negative? Both the ones, because they're going left and down. Okay, so sine of 585 degrees. Sine is always so, opposite over hypotenuse. Opposite of 45 is negative 1. Hypotenuse is the radical 2. You want simplest radical form, so multiply top and bottom by radical 2. And your final answer is negative radical 2 over 2. And you show your check. What mode? 585 is degrees, so we're back to degree. Then we're going to type in sine of 585 to see what we get. So mode, back to degree, and sine of 585, negative 0.707. Some of these decimals you'll start to recognize. I got to type in negative radical 2 over 2. I think we've seen one like that today already. If I do negative radical 2 divided by 2, negative 0.707. We got it right. All right, last one. This will be another good one for you to try. If you can do this one, you've got it. So example 6, I think we're on. Cosine of 14 pi over 3. I'll set you up and then have you pause it. Here's 0, pi over 2, pi, 3 pi over 2, 2 pi. Go ahead, pause it, see if you can figure out what your answer would be, and then check it on your calculator. When you're ready to see the answers, press play. All right, so I'm over 3. So this would be 3 pi over 3. I got to go all the way to 14. What would 2 pi be? 6 pi over 3. Still got to go further. I've got 3 pizza slices. 3 more is 6. 3 more is 9 pi over 3. 3 more would be 12 pi over 3. I still got to go further. 3 more would be 15 pi over 3. So by the time I got to my 14th slice, I'd be in quadrant 2. 14 is just one less than 15. So you can draw how we got here. We went all the way around once. I think we went all the way around twice, and then some. Reference angle over 3, don't even have to think about it, it's 60. Next to 60 is always 1. Hypotenuse is 2. This would be radical 3. What's negative? We went left to get to the 1, so that's a negative over here. And it's cosine. So cosine of 14 pi over 3. Cosine is what side over what side? Adjacent over hypotenuse. So adjacent to the reference angle is negative 1. Hypotenuse is 2. Negative 1/2. Check you should have shown. It'll work out if you change your mode to radian, because 14 pi over 3 is obviously a radian. You're going to type in cosine of 14 pi over 3. Hopefully we'll see negative 1/2. So the mode is changing to radian. And then we're going to do cosine of 14 pi divided by 3, negative 0.5. And you know negative 1/2 is also negative 0.5. Check. All right. So that's what I'm expecting to see on your homework tonight. And again, I'm going slow because this is a really important day. Evaluating trig functions, sine, cosine, tangent of an angle is going to keep coming back a lot more in this unit and especially more in future math classes. I know you've done more than enough examples, but when we're in class, I normally do the first question on the homework with you just so that you know exactly what I'm looking for. So if you want to switch over to your homework sheet quick, or if just another sheet of paper if you don't have a way to print this out, let's do number 1 together. So evaluate each of the following exactly, show your answer by using your graphing calculator. So the work I show for number 1 is what I'm expecting to see for everything. Cosine of 120. Start by drawing it out. So I still want to see 0, 90, 180, 270, and 360. Is that getting tedious yet? I hope so, because I want it to be tedious because that'll be ingrained in your mind. 120 is in quadrant 2. So show me your angle. Then you draw your triangle. Figure out your reference angle. If this is 120, what's my reference angle? I'm attached to 180, so if I subtract those two, I'm going to have 60. Label your triangle. So down next to 60 is always the 1. The hypotenuse is 2. This would be radical 3. Check for negatives. Left is a negative. And then you're evaluating cosine of 120. So cosine, SOHCAHTOA, is adjacent over hypotenuse. If you need to write out SOHCAHTOA up at the top, if that's not ingrained yet, go for it. Adjacent side to 60 is negative 1. Hypotenuse is 2. There's your answer. I also am expecting, I left room down here because I want to see a check. I want to know what mode you're in. So for this one, what mode would I be in? I'd be in degree mode because it's 120. So I'm going to change this back one more time to degree. I'm going to type in cosine of 120. I get negative 0.5, so I want you to show me that. Cosine 120 equals negative 0.5. If this was a radical, I would need you to type that radical in. Since it's negative 1/2, we know that's going to be negative 0.5, and it's good. But if this wasn't negative 1/2, I'd want to see the radical. Then you'd go over here, type the radical in, and compare the big long decimals. All right, so that's what I'm looking for the homework. So please show me that. And if you have any questions, I'm only an email away. Good luck.